The navigation display, ND, can present the pilots with a lot of useful data to assist in the safe operation of the aircraft. Because the ND gives the pilots a visual presentation of where the aircraft is in relation to airfields, nav aids, etc., the operation of the aircraft is also made easier. In this module, we will use the captain's ND. There are 5 display modes available on the ND: ILS Rose Mode, VOR Rose Mode, Nav Rose Mode, ARC Mode, Plan Mode. The modes are selected by the Mode Selector on the EFIS control panel. There are 3 basic navigation display modes: Rose, a 360-degree compass rose; Arc, a 90-degree segment; Plan, a map with north at the top. Before moving on to look at the individual modes, let's quickly look at some common information. The ground speed, GS, and the true airspeed, TAS, are displayed on the top left corner. Below the speed, the wind data is presented. Wind direction and speed from true north is presented numerically. An arrow shows the wind direction with respect to magnetic north. Here, the true wind is from 60 degrees at 52 knots. Aircraft magnetic heading is given by a fixed yellow lubber line against the moving compass rose. Selected heading or track is shown by a blue triangle or blue numbers if out of display range. This is similar to the PFD. Actual track is depicted by a green track diamond. Range marks are displayed by white dotted lines, while range values are depicted in blue. The display range can be adjusted using the range selector. Select the 320-mile range. You can now see more of your flight plan. The range values have changed accordingly. Let's study the ND individual modes. The Rose ILS mode is a raw data mode, providing standard localizer and glide slope deviation bars. Other information is displayed to assist you: an ILS course pointer, ILS information. Select the Rose VOR mode. The Rose VOR mode is another raw data display. On the display, there is a course pointer and a lateral deviation bar. Like Rose ILS, the information about the tune frequency, the selected course, and the nav aid are displayed in the top right-hand corner. Let's now display the VOR bearing pointer. Notice that there is a white VOR bearing pointer and VOR information associated with the pointer. The number 1 pointer is represented by a single line. Let's change the selection on the EFIS control panel to display ADF1 instead of VOR1. This is achieved by moving the number 1 ADF VOR selector to ADF. Select ADF1. The white VOR bearing pointer has been replaced by a green ADF bearing pointer. The VOR information on the bottom left of the display has been replaced by ADF1 information. Notice that the selection of the pointer has not removed the deviation information for VOR1. Notice the tiny underlined M beside the nav aid information, which indicates that the ADF has been manually tuned by the pilots. You will learn more about the nav aid selection in the navigation chapter. Next, we will look at the effect of turning on the VOR bearing pointers. The two white VOR bearing pointers are now visible. You have seen the two raw data displays. Now let's look at the rose nav display. Displayed is a map view of the area surrounding the aircraft. On the EFIS control panel, the range selector is set at 80 miles, which is the distance from the bottom to the top of the compass rose. The green line represents the flight plan that is programmed in the FMGS. This will be discussed in the autoflight modules. The information contained in the top right-hand corner of the display relates to the next waypoint. In this example, the next waypoint is PAS, Papa Alpha Sierra. The information is track to waypoint, distance to go, estimated time to waypoint. The normal mode for the cruise phase is the ARC mode. Click on the forward arrow to select the ARC mode and a range of 160 nautical miles. ARC is the normal mode for cruise. Displayed is the ARC mode and a range of 160 nautical miles. Using the push buttons at the top of the EFIS control panel, additional information can be displayed. We'll discuss the constraint button first. The constraint button is used to specifically label flight plan constraints in terms of time, altitude, or speed constraints. The particular point is always identified by a magenta circle, but the constraint button shows whatever restriction applies at that fix. In this example, note the magenta circle at the intersection Bravo, denoting a constraint. By pressing the constraint button, we can label the constraint. Press the constraint button. The constraint is an altitude constraint. In this case, we must cross Bravo intersection at flight level 180. The airport button will show all airports that are in the displayed range, up to the max of 320 nautical miles. Select Airport. A green light illuminates in the push button. On the display, the airports contained in the aircraft's database and within the area are shown. This is a useful feature when considering diversions. Select NDB. All the NDBs contained in the database and within the display range are shown. Select VORD. All the VORs contained in the database and within the display range are shown. Select Waypoint. The display has started to become very cluttered now that all the waypoints are shown. Select 40 nautical miles. As you can see, the display is a little less cluttered. Now let's look at the final display mode. Select Plan mode. In this mode, the flight plan legs are shown on a true north-oriented map. The center of the display is a waypoint. The aircraft is displayed in relation to the waypoint. In the example shown, the display is centered on waypoint PAS, Papa Alpha Sierra, and the aircraft is heading toward that waypoint. Deselect waypoint. Now, let's increase the range to 320 miles. Select 320 nautical miles. Since plan mode is centered on a waypoint, the aircraft symbol may or may not be displayed. To demonstrate this, we have shifted the display for you and centered it on the waypoint GEN. Notice that the aircraft symbol has moved toward the top of the display.